Good morning, everyone. Welcome to week 2 of linear algebra, math 13217. Today, we will be talking about matrix multiplication or matrices multiplication. Quick start with acknowledgement of countries. So we respectfully acknowledge the traditional custodian of the lands on which we work and learn. We pay respect to First Nations people, their elders, past, present, and emerging, for they hold the memories, the tradition, the culture, and hopes of Aboriginal and Torres Strait Islanders people. Aboriginal and Torres Strait people islanders should be aware that this course may contain images, voices, and names of deceased persons. Okay, so quick recap of what we did last week. So last week we were into introduction of linear equation and how it can be converted into matrices. We have gone through the definition of matrices and what we mean by vectors. Then we talk about transpose of a matrix. Then we talk about some types of the matrices, basic operation, scalar operation, just like, addition, multiplication by scalar. So pretty much introductory section was week 1. Okay, today we will dwell deeper into the matrices multiplication. Okay, so the first thing before we talk about just before we talk about matrix multiplication, we need to understand. It's not just there is one slide. I'll just go to that one. The next slide. Okay. So let's pick up metric A, which is, say, M cross N, or what's the previous one saying? I think it's L cross N. Okay. Then before we multiply it, even think about it, if you're going to multiply with metric B should be M cross N. So what we are saying here is number of, as we know, this is row and column, number of column of A should be same as number of rows of B. If that is not verified, if that is not true, then you cannot proceed with multiplication. Okay, so that's the first definition, that first condition that everyone should check. Okay, so A is a L cross M matrix, B is a M cross N matrix. That is the number of columns of A, that is this M, should be equal to the number of rows of. If that happens, then we will have a multiplied matrix C, which is, remove the common element, which is L cross N. Okay, same number of rows of A times by number of columns in B. Now that will be very tricky to understand it this way. It's a definition and it will be tricky. So each element of the new matrix C is composed of multiplication of elements of A and B, and they're added together. Okay, so I wouldn't explain it now here, but what we are saying, just let's have a look at that one. Okay. So let's say we got a 3 by 3 matrix. 3 rows, 3 columns. Up here, 3 rows, 4 columns. So number of column of A is the same as rows of B. If that happens, the new matrix that will be formed will be 3 cross 4. Okay, 3 cross 4. 3 rows, 4 columns. Now, by now, you should be able to write the matrix in the standard form. Okay, so I'll give you some example going back in this slide over here. So if I say A is, say, for example, 2 cross 3 matrix. If my A is a 2 cross 3 matrix, that means it will have 2 rows and 3 columns. So 1, 2, 3, 1, 2. By default, we will start with A11. The suffix indicate is a first row, first column, then first row, second column, first row, third column. The first element, as we discussed last week, represents row. The second element represents column. Then we go to the next one, A21, second row, first column, second row, second column, second row, third column. Okay, if I want to talk about some matrix C, which is 3 cross 4, right? That means 3 rows and 4 columns. So A11, 1, 2, 1, 3, and 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4. It should have only 3 rows and 4 columns. Yeah. Right. So this is how our C is structured. Okay. 3 rows, as you can see, yeah, and 4 columns. Now, what is C11? Okay, C11 is the sum of the product of the first row of A, because you are talking about 1, 1, and with the corresponding element of first column of B. So this first row will be multiplied with the first column and added together. Okay, when I talk about C12, it is the sum of the product of the first row of A. Again, since I'm talking about 1, 2, first row, second column. If I say 2, 3, second row, third column. If I say 3, 4, third row, fourth column. Okay, so C12 is the first row, second column. So first row of A, which is A11, A12, A13, that will be multiplied with, this is for C12, B11, B21, B31, the corresponding element. So when we say corresponding element, first with the first, second with the second, and third with the third. Okay, so now if I go back to the definition, it will make a bit better sense. So what is Cij? Any particular element? Sigma represents the sum. Aik, Bkj, now the k will be gone, and you will have the elements Aij. But how is Aij structured? So if you let your k is equal to 1, I1b 1j, which will be added to I2 2j up to IM BMJ. I will be 1 to L, J will be 1 to N. This L and N is the new dimension, right? Number of rows and column of C, right? If it's still confusing, don't worry too much about the definition of how C is produced. You should more focus on how to get the elements of C, okay? Right. So let's look at some example. So it's the same matrix, C11, C12, the same one that we had, because it is 3 rows, 3 column, 3 rows, 4 column. This is gone, and this will be 3 rows, 4 column. Okay, 3 rows. So 1, 2, 3, and 4 columns, 1, 2, 3, 4. Now let's look at the individual element of this matrix. So what is C11? First row with the first column. How the rest of them, I just, leave it blank for now. So we don't want to cover all 12 elements. We'll cover them one by one. First row with the first column, 1, 1 with B11, 1, 2 with B21, 1, 3 with B31. That's your first element. Okay. Now, if I go with the second element, C12, what it indicates? First row, second column. Okay. So I picked up the first row here with the second column, first row with the second column. Okay, and then we'll multiply and keep it's in place. Which place? C12 is the first row, second column, but that should go here. Okay. The next one, C13, first row with the third column. Where should it fit? It should fit here. Yeah. Similarly, you keep on going and obtain all the 12 elements of the multiplied matrix. So this is C11. Okay. This is C12. Right? First row, second column. So what I would expect that you take a screenshot of this, right? Or use snipping tool or whatever, and then produce all of the 12 elements. Those who are watching recording, please pause it here, take a screenshot from your mobile phone or snipping tool if you're working on a laptop, and try to obtain all the 12 elements, C11, then C12, then C13, C14, all of them. Yeah. Okay, so I wanted to ask if any one of you see any pattern here. Maybe it will be obvious to point it here. Do you see any pattern? So this element is nothing. Come on. Nothing but C12. Do you see any pattern? So when you multiply the element, okay, what happens? This 1 and 1 is crossed out. So what is left over? 1, 2. This 2 and 2 is crossed out. What is left is 1 and 2. This 3 and 3 is crossed out. What is left is 1, 2. Okay. Now one tip, another one, which I would like to share. Use the pointer or use your hand. If you're doing on a piece of paper, use your hand, right? So what I would do, see, as I highlighted this red block, you can use your pencil to do it, at least initially, until the point you become extremely confident that I know what I'm doing and it's 100% correct. Until that, use the block, use the ruler to hide everything else, right? Or your hand. So if I'm looking at this, I would literally keep my hand on the second, third row of A matrix and everything else on the right of B, right? And just focus on the first row, first column. Everything else is hidden. You can use your pen, ruler, whatever helps you. So you're just focusing on those elements that will stop your distraction, right? Okay. So first with first, follow my pointer, A11 with B11 plus 1, 2 with 2, 1. So A12 with B21 plus A13 with B31. Okay. Then the second element, again, what will happen? What is the second element? C12. The suffixes indicate you are multiplying the first row with the second column. So first row of A, second column of B. Now hide everything else. It's only first row and second column. A11, B12, A12, B22, A13, B32. Okay. Next, we are talking about C13, right? C13, first row of A multiplied by third row of B. A11, 13, 12, 23, 13, 33. It has to be always row with column, not row with row, not column with column. If by mistake you do that, okay, say by mistake you did first row of A with the third row of B, I'll tell you what will happen. Okay, first row of A with the third row of B. Instead of column of B, say by mistake you chose third row of B, what would happen? 1, 1 with B31, 1, 2 with B32, 1, 3 with B33. This element is left over. So it should alert you that something is wrong, right? To keep it simple, row with column. Just take your pointer or hand wherever it says. Say, for example, if you're talking about C31, obviously you are picking up the third row with the first column. Okay, now let me run all of them. And again, if you struggle, any doubt, please email me, contact me, after watching the recording and after doing certain hours of practice. Yeah. Okay, so again, as I said, the pattern is we are able to eliminate the common number. So what is left over? 1, 1, 1, 1, 1, 1 is left over. The same thing can happen with all the elements. If I'm talking about C13, first row with the third column. So while you are looking at this, please keep your screenshot of A and B and D here. Or maybe I can post them here as well. I'll update the slide. Yeah, I'll post them there. Yeah, I can do it. That will take some of my time. I'll do it later before I upload it. Yeah. So when you're watching it, it will make sense. C13. So first row with the third column of B. Again, the pattern is the common element will be cancelled, leaving the suffix. Sorry, C33 is a typo here. Right, and similarly keep going. So 1, 4, 1, 4, 1, 4 is left over. And we keep going for all the elements. So C21, second row of A with the first column of B. C22, second row with the second column, second row with the third, second with the fourth, right? Similarly, 3-1, 3-2, 3-3, 3-4. When you talk about C34, third row of A with the fourth column of B. Okay, so this is how they are all put together. And that's why I dropped going too much deeper into the definition of multiplication where that sigma form was there, right? Okay, again, if you got any question, if you fail to understand it, don't worry, shoot me an email and then I'll help you at my best ability. Okay. Right. With our practice, looking at this looks awful, horrible, you won't get it. So let's go and do some practice, okay? Right. So we got metric A, metric B, right? Which of them is defined, first of all? Is it the BA or AB? It could happen both of them are defined. It could happen one of them is defined. So let's first of all check it. Okay, let's say if I wanted to talk about BA. What is B? This is 3 rows and 2 columns. This is 2 rows and 2 columns. So 2 by 2 and 3 by 3. Column of B is not the same as rows of A. So this one is not defined. But if I talk about AB, this is 3, 2. This is 2, 2. Same number. The outcome will be a 3 cross 2 matrix. So that's the first point you should check. Whether AB is defined, whether BA is defined, it may happen none of them is defined. That's fine. Just move forward. If none of them is defined, that metric multiplication is not possible. Explain the reason why it's not possible. If it is possible, yes, it is possible. Here how it's done. Okay, so first step is to check whether the multiplication is defined or not. Okay, now, since the multiplication is defined, we will produce the new metric 3 by 2. The first point, until you become very confident in multiplication, is to write down the element in this form. This is a very important step. I would request everyone, don't skip it unless you are a pro in multiplication. And when you are teaching in a classroom, assuming that you will teach this concept in the classroom, please advise your students to use this step. Don't skip it. It's only a couple of seconds, but it will be produce more accurate result. Right. So this is my guiding tool. I'm talking about C11, C12, C21, C22, 31, and 32. And this is very easy to produce, right? It's following the same notion of a metric. 1, 1 indicates first row, first column. 1, 2 indicates first row, second column, right? Then I got 2, 1. So 2, 1 indicates the second row, first column, second row, second column, third row, first column, third row, second column. I will not go any further because I only got 3 rows and 2 columns. Cool. Let's keep going. Now, C11, what do we do? As we practice in general, is a first row with the first column. First row with the first column. Again, the first row with the first column. So move your fingers, right? 3 times 1. So point it right there. Okay, plus 1 times minus 2. That's done. That's your C11. Move to the next. C12. What it says? First row, second column. First row, second column. 3 times 2 plus 1 times 1. C21, second row, first column. This is your second row. This is your first column. It will be very easy to get confused because the elements look so repetitive. 3, 1, 2, 3, 1, 2, minus 2, okay? But that's why use your fingers and hand, okay? Second row, this is second row, first column. 2 with 1 and 2 with minus 2. 2, 2. Second row, second column. 2 with 2, 2 with 1. Okay? Third row, first column, 1 with 1, 3 with minus 2, 1 with 2, 3 with 1. Okay? And then it's our basic number multiplication, addition, subtraction. Simplified. 3 minus 2 is 1, 6 plus 1, 7, and so on. This is your, the new, this. Skip. Okay. Cool. Right. Again, any question? Let me know. How about we try it? Oh, it's the same thing, isn't it? It is in repeated. Is it the same thing? 1, 7. Yeah, it's the same thing. I don't know why it's been repeated. Okay. How about we try this one? Or do you want me to explain one more? Okay, so the good days are here. Is both 3 by 3. So AB and BA, both of them will be defined. And trust me, they won't be same. Right? They could be, but not in general. Right? Okay. So let me start with AB. Right? So as I said, the first thing is to produce this metric 1, 1, 1, 2, 1, 3. Write it down. 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Since both of them are 3 by 3, the outcome will also be 3 by 3. Yeah. Doesn't matter you talk about AB or BA. They both are 3 by 3. Different, but 3 by 3. Okay. Right. So before I say it, you should say it to yourself. What is C11? Say it to yourself. If you're watching the recording, attending the class, C11. Tell it to your mind. What is C11? First row, first column. First row, first column. So I would literally block everything else. And then move your fingers. 2 with minus 3, 0 with 2, and 1 with 0. Move your fingers, right? As I'm pointing, use the laser pointer. 2 with minus 3, 0 with 2, and 1 with 0. That's what I've written here. Okay, the next one. Okay, what is the next element? C12. Say it to yourself. What is C12? First row, second column. So I would go with the first row and second column. Block everything else. Don't say anything else. Just focus and move your fingers, right? Move your fingers as you start calculation. 2 with 1, 0 with 0, 1 with minus 1. That's your second element. For the third element, right? I will just, cancel the blocks and just erase the blocks. Okay. Now follow with the laser pointer. 1, 3, first row, third column. 2 with 0, 0 with 1, 1 with 3. That's your third element here. 2, 1, second row, first column, -2 with -3, 3 with 2, and 2 with 0. 2, 2, second row, second column. Please say it the way I'm saying it, right? Because if you keep on repeating what I'm saying, you will eventually understand. It's only like spending, I would say, 1 or 2 or max 3 hours in absorbing it, because you might be looking at it for the first time. You haven't seen it earlier. So it's very much understood that you will not understand it in the first go, not absorb it 100%, that's fine. If you keep on repeating, looking at it, feeling those numbers, rows and column, it will be very easy. Right, 2, 3. What does it say? Second row, right? Second row with the third column. Second row with the third column, -2 times 0, 3 times 1, and 2 times 3. Okay, wherever there is a minus, just put some bracket. So it's very easy to observe. Okay, 3, 1, third row, first column. Third row, first column. 4 with -3, 1 with 2, and 5 with 0. 3, 2, third row, second column. 4 with 1, 1 with 0, and 5 with -1. 3, 3, third row, third column. 4 with 0, 1 with 1, and 5 with 3. That's it. And then this is all just addition, subtraction. -6 plus 0 plus 0, that leaves -6. 0 plus 1 plus 15, that's 16. Yeah, similarly, you can fill all the elements. Again, a word of advice here. Even though it's done here, redo it. This is what I tell my students from all the time. See, should be a different approach for math. And since you are the future of the education industry, whatever practices you do, you will see rewards of it, and you will tell your students. There's a whole chain. They will learn it the way you teach them, right? So what I would encourage you guys is never look at a board or a screen and copy the numbers. That way you are developing your understanding, not your analytical thinking, right? But the moment you redo it, that, okay, it's done on a screen. I won't copy the numbers from the board or the screen. I would redo it. Of course, you will make mistakes in redoing it, but that's fine. Every human is bound to make mistake, but this is how we learn. But if you are afraid of making mistake and simply copy from the screen or the board, you are destroying your analytical thinking and your ability to absorb concept for longer duration. Right? And this is a proven technique. It works with most of the students whom I tell them. It's just that gut feeling that no, I will not copy it. I will do it by my hand or piece of paper or screen, pen, whatever, virtual pen, notepad, whatever, but do it, not copy it. Okay. Right. Let's keep going. Again, any question, get in touch. Right. So how about you guys doing it now? It was done on the last screen. I hope you understand it. Give it a go, and then we'll verify it. Okay. Okay. So we had some practice here and we got very good success rate. I wish you the same. I already explained this. Please practice it. Again, any doubt, get back to me. Okay. Let's get going. Again, I would request, see, this is a lecture come workshop. So it's not like a lecture where a lecturer or a professor is talking about and you're like, wow, it's a good lecture, just relax on a couch or something. No, maths is always about doing the questions. If you won't do it now, you'll have to do it later on. right? So my approach is we do it together. When you're watching the recording, pause it, right? And do it. If you're live in the classroom, I will pause the recording while everyone with me are practicing. We got abundance of time, right? The lecture are scheduled to fit 3 hours and we got enough time, okay? So those who are watching the recording, pause it, try it, okay? And verify whether your AB is the same as BA or different, okay? I'll pause it here. Please give it a go. For all, you keep doing that for all the elements, right? So this is how your AB should look like. First row with the first column, 1 with 4, 2 with 2, right? Then the second element, first row, second column, 1 with 3 and 2 with 1. Second row, first column. So that's your 3, 4 plus 4, 2. And then 3, 3 plus 4, 1. So that's 8, 5, 20, 13. But if you talk about BA, right? That's first row, second column. The elements, the numbers are same, but in a different order. So 4 times 1, 3 times 3, and you keep going for rest of them, you obtain different metric. As you can see, 8, 5, 20, 30, 13, 20, 5, and 8, right? Since A and B have the same numbers in different places, your A, B, and BA will be different, but could carry the same numbers. And thus, your AB is not same as BA. Right. Okay. Multiplication of two vector of the same size, right? So row vector to a column vector. So let's say you got a row vector that has only one row, right? What is the dimension of this element? This metric, one row with n columns. This is n row. Sorry, this is Bn, not 4. Yeah, n row with one column. Right? What you will obtain is 1 by 1 metric. 1 by 1, just one element, right? First with first, second with second, third with third, and nth with the nth element, right? So if you got 1 cross 3 and 3 cross 1 here, the outcome is a 1 cross 1 metric, 1 with 3, 2 with 2, and 3 with 1. Simplify that, you'll obtain 10, which is a 1 cross 1 metric. Okay. Now, a column with a row. Okay. You got n rows here. N rows here, one column. You got what? One row and n column. The common element will vanish and you'll obtain a metric which is n cross n. Okay, with each element, first with second, right? Third with third, first with n, second with 1, second with 2, second with n, and so on. This is the general form of it. So if you talk about D, which is B cross, say 3, 2, 1, and 1, 2, 3, this simply swapping the order changes everything, right? Okay, so this is 3 row, 1 column, 1 row, 3 column. The outcome is 3 by 3 metric, right? Obviously, there is only one element, so you won't add anything. First with first, second with second, first with second, third with third, and complete as per the definition. Okay, let's look at some rules of metric multiplication. So what we have observed so far, that in general, AB is not the same as BA, right? Like I was mentioning it in the previous session, we are now talking about linear algebra, metric addition. So matrices is not a number, is an arrangement, rectangular arrangement of number, right? So whatever properties we know for the real numbers. So for example, if we talk in mathematical language, the numbers addition is commutative. What it means is a plus b is same as b plus a. 2 plus 7 is same as 7 plus 2. Is it true in matrix addition? Is a plus b same as b plus a? Answer is yes. The next thing goes with the associative law, the commutative law, multiplication by scalar, you know. But in general, not everything is commutative, or, like subtraction is not. 2 minus 3 is not same as 3 minus 2. So whatever rules we have for the real number, we are trying to establish or verify them for the matrices system as well. Now we are talking in a different system, right? There are numbers, there are real numbers, but that's an arrangement of real numbers. Okay, so this is called distribution property. Addition over multiplication. This is multiplication over addition. So AC plus BC, yes, is true. This is CA plus CB. Don't write in a different order. This is not same as AC plus BC, as we know that multiplication is not commutative, not in general. Okay, if we have a constant lambda, which is 2, 3 or something, Greek alphabet, we wanted to keep it different from the normal A, B, C, D, right? It can be left outside, it can stay with A, or it can stay with B, doesn't matter. It will produce the same outcome once everything is simplified. Right, multiplication is associative. So if you have A with BC, it will be same with AB with C. A with I with A is AI is a unit metric. It's the same saying 5 cross 1 is equal to 1 cross 5 is equal to 5. Similar to this, right? Which we know for real numbers. The existence of identity, existence of unit number or unit metric. Okay, this is transpose. AB transpose is the same as B transpose times A transpose. Okay, let's keep going. Now, this is something that you will practice, you will try. So what I want you to do now, you got matrices A and B. The numbers look familiar, something that you would have done recently. Obtain AB, talk about its transpose. Just to refresh your memory, transpose is changing row into column. So say, for example, if my P is 11, 12, 13, 14, then P transpose will be 11, 12, 13, and 14. First row becomes first column, second row becomes second column, right? So those who are watching recording, please pause here. Obtain AB, the multiplication, and its transpose. Obtain B transpose, A transpose, and multiply them. And you should be able to verify that they are both the same. Okay, so let's start with AB first of all. One, two, three, four, 4, 3. First with first. So 1 with 4, 2 with 2. I'll just write it so those who are still not clear will gain more understanding. First row, second column, right? First row, second column. Second row, first column. 3 with 4, 4 with 2. And second row, second column. 3 with 3 and 4 with 1. Once you simplify, you will have 8. Up here we got 5. That's 20, and this one is 13. And therefore, AB transpose will be 8 and 5, 20 and 13. Okay, lock it and call it equation number 1 or result number 1 or whatever you. Yeah. Now, We are not obtaining B transpose A transpose separately. I'm going to the next step directly, which is BT times AT. So what is BT? 4, 2, 3, 1. What is AT? 1, 3, 2, 4. Again, I'm going to write all the elements. First row, first column. So 4 times 1 plus 2 times 2. First row, second column. That is 4 times 3 plus 2 times 4. Second row, first column, 3 with 1 and 1 with 2. Second row, second column, so 3 with 3 and 1 with 4. Once you simplify it, you obtain 8, 25, and 13. And therefore, B transpose multiplied with the A transpose is this. Again, make a nice block, call it result 2 from 1 and 2. I can verify that AB transpose is B transpose times A transpose. Happy days. Well, wasn't too bad. Yeah, it's all about practicing them. Right. Please verify this one. Okay. What we are doing, you're obtaining AB and then multiply with C. In the right-hand side, you obtain BC first and then multiply with A. Okay, so let's jump on. So we'll start with the left-hand side. AB. So AB is 1, 2, 3, 4, 4, 3, 2, 1. It's a 2 by 2. I'm going to do it directly, otherwise there'll be so many number of steps, right? So 1 with 4, 2 with 2, so that's 8. 1 with 3, 2 with 1, so 5. 3 with 4, 2 with 1, so that's 20. 3, 3, and 4, 1, so that's 13. We already have obtained such things earlier, right? Now AB with C. So what is AB? 8, 5, 20, and 13. C is minus 2, minus 1, 1, and 3. Be very careful when you deal with the minus. Okay. 8 with minus 2, so minus 16, plus 5 with 1, right? So that's minus 11. 8 with minus 1, so minus 8, 5 with 3, 15. 15 minus 8 is 7. 20 with minus 2, so that's minus 40, plus 13 with 1, so minus 27. 20 with minus 1 and 13 with 3, so minus 20 plus 39. Say it the other way, 39 minus 20, so that is 19. Call it result 1. Now we obtain BC. BC. B should come first, so 4, 3, 2, 1 times by minus 2, minus 1, 1, and 3. 4 with minus 2, 3 with 1, so that is minus 5. 4 with minus 1, 3 with 3, so minus 4, that's, can I say plus 5? Yeah, minus 8 plus 3, that's minus 5, minus 4 plus 9, that's plus 5. 2 with minus 2 and 1 with 1, minus 3, 2 with minus 1 and 1 with 3, that is plus 1. Okay, now A with BC. A is 1, 2, 3, 4 multiplied by BC. It should be the same. So don't try to push it to be the same. Verify it. Moment you verify, there might be some mistakes. Right? Okay. So minus 5 minus 6, that is minus 11. 5 plus 2, that is 7. Minus 15 minus 12, that is minus 27. And 15 plus 4, that is 19. So they are exactly the same. It's a theorem, it's a proved formula, so it has to be the same. If it is not, go back and check it. Okay, so finally AB with C is the same with A multiplied with BC, hence proved, hence verified. Yeah. So I believe that was easy to answer. You will make mistake. That is absolutely normal, but please keep on practicing it. Again, remember what I said. Do not copy it from the screen. Do it. So you will make mistake. I mean, you might make mistake and we learn from it. Okay. Again, one more question. Give it a go. So what we are doing, we are finding A plus B, whatever that matrix is, multiplied with C. On the right hand side, we are finding AC, we are finding BC and adding them up. Please give this a try. Okay, so as I mentioned, first point is obtaining A plus B, right? Is a pointwise addition. So 1 plus 4 is 5, 2 plus 3 is 5, 3 plus 2 is 5, and 4 plus 1 is 5. Okay, now we'll do A plus B multiplied with C. 5, 5, 5, 5 multiplied with C, minus 2, minus 1, 1 and 3. So that will be minus 10 plus 5, so minus 5, minus 5 plus 3, that will be, minus 5 plus 15, that will be 10. Since all the elements are 5, the second row has to be the same. So that is minus 5 and that is 10. So this is your A plus B multiplied with C. Result 1. AC. 1, 2, 3, 4 times by C. Okay, that will be minus 2 plus 2. So that's a 0. Minus 1 plus 6. So that's a 5. Minus 6 plus 4. That's minus 2. And minus 3 plus 12. So that is 9. Now we go for BC. 4, 3, 2, 1 with minus 2, minus 1, 1 and 3. Minus 8 plus 3, so that's minus 5. Minus 4 plus 9, so 9 minus 4, that's plus 5. Then I got minus 4 plus 1, so that's minus 3. Minus 2 plus 3, so that's a 1. So the moment I do AC plus BC, add them together, that would be minus 5, 10, minus 5, 10. So AC plus BC is that. Result 2. From 1 and 2, we can confirm that this result is verified. Okay?
Yeah, I'm mistaken multiplication of AC, that's why it's well,
Oh, you mix it up?
yeah, mine one came minus 1, 2, then minus 3, 9, that's why.
Yep.
Messed up.
It's happened. It happens, but it's good that we are practicing. We are finding our mistake and improving on it. That's good. Okay, we got a few more questions to cover. Right. So this is called multiplication is not commutative, right? So we got A plus B here, A plus B, same metric. So it's like C times something is not that something times C. So matrix multiplication is not commutative. Okay. So those who will watch the recording, you can pause it here and practice it. Those online, practice it with me. Like I will not say a word, let you practice it. And then, we discuss it together. Okay. Okay, so first step is finding out A plus B. So we got 5, 5, 5, 5. It's the same number, right? Then you have C with A plus B, multiply it, you obtain result 1. A plus B multiplied with C. By this time, we have done enough multiplication factors. So I'm sure you are confident in doing the multiplication. And obviously from 1 and 2, they are not the same. I want you to practice this. It's a 4 by 4. So there'll be 16 elements. Let's give it a go. Okay, so AB. Both of them are 4 by 4. By 4. So our AB will be also 4 by 4. Okay. If you want for such a case, you don't have to write everything step by step, but if you want, you can always call AB as C11, C12, 13, 14, 21, 22, 23, 24, 31, 32, 33, 34, and 41, 42, 43, 44. That will help you to pick up the accurate row and column. Okay, C11, first row with first column. Follow the pointer. Okay, where is the pointer? My pointer is right here. First row with first column. So 1 with 3, that's 3. Keep putting everything in mind. I mean, you can write on a piece of paper if you want, right? 2 with 2, 3 with 1, and 4 with 0. Again, 1 with 3, so that 3 plus 4 plus 3 plus 0. So that will be 10. Okay, first row, second column. So 1 with 1 minus 4. So that's minus 3 plus 0 plus 0. So that is minus 3. Then the next one, 1 with 0 2 with 1, so that's 2 plus 6, so that's 8 plus 12, so that is 20. Next is 1 with 1, so 1, 2 with 0, so that's 0, plus 3, that's 4, plus 4 is 8. Okay, that's your first row. Next, you can be quicker if you want. 2 with 3, that's 6, plus 0, plus 2, plus 0. So 6 plus 0 plus 2, that's 8. Okay, 2, and then everything is 0, 0, 0, that's 4, plus 0, 1, sorry, so that's 2, 0, 2, 0. So that's 4, 9 plus 2, that's 11, then 0, 0, 1, then everything else is 0. So that's just 1, 3, 0, rest everything is 0. But that's, oh, sorry, I did miss something. My bad. Okay, again, third row. See, sometimes the pen and the mind are not aligned. Yeah. Okay, so again, 9 plus 2, that's 11, the rest are 0. See, when you are doing like this, since these two elements are 0, I will not worry about it. With whatever that will be multiplied, they're going to be 0. So just focus on the first two element. Okay, so 9 plus 2, that's 11. The next one, 3 minus 2, so that's 1. Yeah, 0 plus 1, that's also 1. 3 plus 0, so that's 3. Because they are 0, so whatever you multiply with them will be 0. Same thing here. This middle two are 0. So focus on the first and last. Okay, so 12 plus 0, so that's a 12. 4 plus 0, so that's a 4. 0 plus 3, so that's 3. And 4 with 1, so that's 5. Okay, I believe it's correct. I'll verify it once more. 1, 2, 3, 4. So 3 plus 6. 3 plus 6 plus 3. No, first one is wrong. Sorry. 3 plus 4. Sorry, 7 plus 3. No, that's fine. 10. 1 with minus 2. So that's minus 3. And those are 0. So minus 3. Yep. 0, 2, 6, and 12. Yep, that's 20. 1, 0, 3, and 4. That's it. That's right. It's 8, 2, 4, 2. Okay, that's also right. 9 plus 2, 11. 3 minus 2 is 1. 0 plus 1 is 1. 3 plus 0. Okay, that's also right. 12. That's 4. 3, yep. 4 plus 1, 5. Okay. To me, this looks correct. Okay. Now, I wanted to bring one thing to your attention before we finish it up. Okay. Only to verify your answer. Only to verify. I mean, you might have a scientific calculator which will verify it for you, but just go online and, just Google it online, matrix multiplication. Okay. What is the dimension of the matrix? So we are talking about a 4 by 4. It will not allow if it's not aligned. Yeah. Okay. Now set matrices. First column first. So 1, 2, 3, 4. 2, 0, 2, 0. 3100 4001. Okay, metric B 3101 2 minus 210 1 0 1 and 0031 and calculate it. So what we got? 10 minus 328, 8244, 11113, 12435. That's the one, and this is what we have obtained. Yeah, 10 minus 328. And if you want, you can show the solution. It will do everything step by. That's your metric A, that's your metric B, C11. First row with first column. So it tells you that's your first element. And then next, and then next, then next. Same thing which I presented in a slides in today's session before a while, the initial few slides, step by step. They'll do it for you, right? So how did I obtain it? Just go online matrix multiplication, the first or second website, the one with the green tick. So that's a safe website to visit without any viruses or anything. And that's it. So thank you very much for coming today. And I hope you enjoy the rest of your week. Any question, just let me know. Happy to help. Thank you. Take care.